Diesel exhaust actually emits less carbon dioxide, carbon monoxide, and hydrocarbon emission than a catalyst-equipped petrol engine. It's the particulates that are a tiny particle of soot which produced black exhaust smoke, and the NOx emissions from the diesel engine which are greater. The emission control system, in which the exhaust gas recirculation system performs a major function, is aimed primarily at reducing the NOx levels. Exhaust gas recirculation, as its name implies, directs a proportion of the exhaust gases back to the inlet manifold to supplement the combustion air. This reduces the oxygen content and lowers the combustion temperature to reduce NOx emissions. EGR functions only when the engine is at operating temperature and is under light to medium load conditions. Although the system varies slightly from model to model, the basic operation remains similar. The EGR systems of some engines, for example, comprises EGR valve, 3 solenoid vacuum valves, a control unit, a throttle control device with a throttle valve, and a potentiometer linked to the injection pump accelerator lever. Note that the throttle valve is fitted purely to assist the exhaust gas recirculation system. It's not in any way used to control the engine output. The control unit received an input signals from the coolant temperature sensor, engine speed sensor, and potentiometer. The signal from the speed sensor mounted at the bottom of the timing case and the potentiometer are used to calculate the engine load. When driving under light load conditions, solenoids 2 and 3 are energized and opened. Vacuum from the engine-driven pump is thus directed to the EGR valve and the throttle control device. The valve opens, and exhaust gases are recirculated to the inlet manifold. At the same time, the throttle control device almost closes the throttle valve. Its action creates more manifold depression, resulting in more exhaust gases being drawn into the cylinders. If the engine load increases, solenoid 2 closes, and solenoid 1 opens. The vacuum now acts on a different part of a throttle control device, causing the throttle valve to open about halfway. The depression is subsequently reduced, and so is the quantity of recirculating exhaust gas. If the load increases further, solenoid 1 is closed, the throttle valve opens fully, and the recirculation quantity is further reduced. When the engine is cold, or during heavy load, or when accelerating or changing gear, all the solenoid valves are closed. The EGR valve shut, and the exhaust gas recirculation ceases. Some models are fitted with just an EGR valve, the throttle control device and its 2 solenoid valves not being required.